Hello everyone. Now I am going to explain you about a topic on capacitance of a parallel plate capacitor. So before that, first of all, we know the basic definition of capacitance. It is defined as a ratio of magnitude of the charge on one of the plates to the electric potential or potential difference. Nothing but it's a ratio of charge to the electric potential, and it's a farads or coulombs per volts. Okay, whenever you have to find out the capacitance of a parallel plate or spherical or coaxial cable, first of all we have to find out the overall charge, and we have to find out the what is the electric potential or potential difference we are applying. If you are able to find out these two, it will be easy for you to find out that overall capacitance. Okay, so now I am going to explain you about the capacitance of a parallel plate capacitor. So for that purpose, here I am considering two parallel plates. Okay, so let us assume this is a one infinite sheet. Okay, so let us assume this is a sheet one end, and another end will be here downside, okay, which is of the infinite length. So let us assume it is plate 1. Similarly, take another plate 2 and take the infinite sheet 1, and another end is infinite 1, second end is keep here, okay, which is nearer to the plate 1, and the distance between these plate 1 and plate 2 is d, and here to find and distribute the positive charge on plate 1 uniformly and negative charge on plate 2. Okay, so here we took the two infinite sheets. So one end is we are calling it as plate 1, second sheet another end is calling it as plate 2, and we are keeping it with a distance of d, and the charge is uniformly distributed with a positive charge on plate 1, negative charge on plate 2. So as we know, these two are the sheets. Okay, so it's charge at the whenever the charge is distributed, charge density become rho s. Okay, if it is a line, it will be rho l. If it is a surface, it will be rho s. So it is minus rho s, and it is a positive charge plus rho s. To calculate the electric field intensity, here I am taking one coordinate system, which is a Cartesian or rectangular coordinate system, where its coordinates are x comma y comma z. Okay, so to calculate that electric field intensity, or capacitance, here first of all I have to calculate the what is the net charge. So the net charge of an infinite sheet is nothing but q is equal to rho s into a, its area, sheet area. Okay, so the net electric field intensity of this plate 1 is E is equal to what? E is equal to, as we know, it is derived na, E is equal to rho s by 2 epsilon into a z value. Okay, because this is a positive side. Similarly, from plate 2, the electric field intensity E2 is equal to what? Here the charge density is minus rho s. Okay, so this minus rho s, which is against to this z direction. So therefore E2 is equal to minus rho s by 2 epsilon naught into minus az. So E2 is equal to rho s by 2 epsilon naught into az value. Minus into minus become plus, will be az. So therefore the total electric field for a parallel plate is E is equal to E1 plus E2. So which is rho s by 2 epsilon into Az plus rho s by 2 epsilon into Az. So therefore the overall electric field is rho s by epsilon into Az value. So make it as equation 2, and here make it as equation number 1. Next we have to calculate the electric potential. So this electric potential means whatever the work we are doing against the gravitational force, okay, that is called as electric potential. So which is V is equal, denoted by a letter V. V is equal to, this is a minus, because why we are keeping minus means we are doing a work which is against the gravitational force. So it is minus. So upper plate to lower plate, E dot dl. As we know the value of E from the equation 2, therefore V is equal to, like upper plate is distance d, lower plate is distance 0, okay, and E is equal to rho s by epsilon naught into Az into dl here, okay, because it is a line. Yes, therefore V is equal to minus d20 rho s by epsilon Az into, whereas we know it is differential line, so therefore it will become dx into ax plus dy into ay plus dz into az. So here we have to take down the dot product of these two. As we know, this is upon simplifying this, we are getting rho s by epsilon into dx into az dot ax. We know the dot product of unlike vectors is 0. Similarly, az dot ay is 0. Similarly, az dot az becomes 1. Means hence we are getting only one term. This is minus into d2 0 rho s by epsilon into dz value. So minus into d2 0 rho s by epsilon into dz value. So take this term to outside. So this it will become minus rho s by epsilon naught into constant of constant. It will become one constant. So constant of this value is nothing but z value. Apply the limits. Okay. So therefore here we are getting minus rho s by epsilon into this is 0. Apply the upper limit 0. Lower limit is t minus t. So here we are getting minus into minus plus means we are getting rho s by epsilon into d value. Therefore V is equal, electric potential is equal to rho s into d by epsilon. Therefore capacitance Q is C is equal to Q by V. Upon substituting this, we are getting Q is equal to rho s into A and V is equal to rho s into d by epsilon. So therefore upon simplifying these, we are getting a capacitance C is equal to epsilon A by D. And when we know epsilon is a permittivity, and which is equal to absolute permittivity, relative permittivity. Therefore, the parallel plate capacitance C is equal to epsilon A by D, which is equal to epsilon naught into epsilon R into A by D. And it's a farads or volts per meter. Thank you.